So with this theorem, c is any constant and r can be any exponent. So I just need to have x raised to some power. So I created a couple of examples here. So I have my constant is 1 and my exponent is 1. And the second version B, my constant is 3, my exponent is 2. But if you remember from parent graphs, 1 over x, of course, looks like this. The 3 over x squared, because it's squared, is going to flip this section right here up into second quadrant. And so really I'm just going to get some combination thereof in one of the quadrants, or two of the quadrants rather. And so I can see, and if I remember about the parent function, that it's getting closer and closer as I go to negative and positive infinity, and negative infinity, it's getting closer and closer to the y-axis, or 0. Okay, so the shocker just in. Apparently I'm delusional about this being in your P note. Although I do know, hopefully, your Algebra 2 teacher and your pre-calculus teacher should have taught you these rules. But who knows there. Okay, so now, if I want to figure out the horizontal asymptotes, we have discussed this in class. I can look at the degree of the numerator and denominator, and here's how I sort out. If, I'm going to pause this and then it'll just poof appear and then I'll talk about it. Okay, so I have three scenarios. Either they're equal in degree, and if that's true I use the leading coefficient over leading coefficient, or, whoops, the numerator is smaller, which is always y equals 0, or the numerator is bigger, and therefore I don't get a horizontal. Now, if it's bigger by exactly 1, so let's say I have a 4th degree power on top and a cubic on bottom, then I will get a slant asymptote, which you can find using long division. Well, those will pop up once in a while. They're not a big deal. But you do need to remember leading coefficient over leading coefficient for if they're equal, y equals 0 if it's less than, and just that there's no horizontal if the degree of the numerator is bigger. So now keep in mind that that works when I have nice rational polynomial functions, but I might not always have that. So in order to figure out if there's 2, I'll need to look at those limits. So the one is x goes to positive infinity, and the one is x goes to negative infinity. And I'll have to do this with piecewise functions or functions with radicals. So I want to look at this first example. So when I look at this particular rational polynomial function, I can't really tell what the degree of the denominator is because although there's a squared on the inside, overall there's a half out on the outside. And of course I can't just distribute that, so I'm kind of stumped. So one way we can fix this to work with it is to divide by the highest power of x, which for this problem is x. But I'm going to strategize on how to divide by that. So now I'm looking at the limit as x goes to positive infinity and the limit as x goes to negative infinity. So for the positive version, so when x is positive, oops, that's supposed to be a 4, not a fro. I'm going to divide top and bottom by positive x, but I'm going to do a fancy form on bottom. And perhaps it's better to say I'm really multiplying by some value of 1, and in this case that value of 1 is this.